Now that we've finished studying all of the different inference methods that we will in this portion of the class, now it's time to decide how do you determine when you've read a question or looking at a particular context, which method should you use? Well, here are some things to consider. So, in general, a significance test is used when the word evidence is used in the context of the problem. And it also needs to be used when the direction of an effect is implied in the question. So if you're looking for evidence of something that is higher or lower or more than or less than something else, and that direction is what is specified in the alternative hypothesis, so that's important. That's when we use a significance test. So a confidence interval is used when the question implies that we're trying to capture the size or the magnitude of an effect. So how big might a particular mean be, or how small might a particular percentage or difference be? So it can also be used in place of a significance test when the alternative hypothesis is a not equal to alternative. This is called a two-sided test, or sometimes it's called a two-tailed test. So this is the case when the question indicates we want to find evidence of a difference. So when we see that word difference, that would suggest a not equal to alternative. I will be really honest though, if you have a question that is specified using the word evidence, you really should do a significance test instead of completing a confidence interval in terms of the way the AP exam is written. So that is decision number one. Decision number one, read the question carefully enough to decide if it should be a test or an interval, if one of those methods should be used and which method should be used to complete your inference. So the next question is to decide what type of data that you will have in this scenario. So categorical data implies that we are working with proportions. Proportions or percentages, we write those as P. So when you have categorical data, that means that you can identify successes and failures. That's important. Categorical data, you have to be able to identify successes and failures in order to create proportions and percentages. So quantitative data implies that we're going to be working with means or mu's. So again, quantitative data, data where we don't have successes or failures, data where we are collecting numerical observations like blood pressure, cholesterol level, the chassis length of an automobile. There's all infinitely many types of quantitative data that we can collect, but in this class we'll be taking that quantitative data and working with it in terms of means or mu's. So that's the second decision. So after you've decided whether the question requires a significance test or a confidence interval, then you need to decide, are we going to be working with P or are we going to be working with mu? And the way to decide that is the data categorical, where I can identify successes and failures so I can create proportions and percentages, or is the data quantitative? Then the last decision to consider is whether the tests or intervals, whether they're for proportions or means, doesn't matter. We can use tests or intervals. We can work with proportions or means in one sample situations, in two sample situations, or we could also have paired situations. Those occur with means. So let's talk about that again. So in a one sample situation, that could be a one proportion situation, or it could be a one sample situation where you're working with a mean. In a two sample situation, you might be working with two proportions. You might be working with two samples where you're going to be thinking about the mean in each of those samples. So in a paired situation, typically in a paired situation, what we have are observations, pairs of observations from the same subjects. And for each pair of observations, we are going to look at the difference between those two observations. So that is not a two sample situation, that is a one sample situation. Yes, we have two observations, but those observations are not independent because they come from the same subject or the same experimental unit. So when the observations are paired that way, we look at the differences between those observations. That's what we mean by a paired situation. And typically those involve looking at an average difference. So those involve means typically. So now it's time to actually look at the calculator screens. I have put on this handout screenshots of the calculator commands from the units that we've studied so far, and I want to make sure that you can find on the calculator the commands that you need in order to complete particular tests. So the simplest commands to identify are the ones with proportions, because they have to have the term prop in them. So for instance, if you want to complete a one proportion z-test, so if you have a test that's working with categorical data and it is a one sample situation, that means you only have one proportion, you should be working with a one prop z test, I would write it out this way: one proportion z test. So instead of a test, if you were going to work with a confidence interval, so if you have from the statement of the question, it's clear you need a confidence interval, you're working with categorical data, so it will use P, and if it is a one sample situation, so you need a one proportion Z interval. That is way down here. It is important when you're working with proportions, it has to say prop. So this is a one proportion Z interval. So, bottom line then, if you're working in two sample situations, but if the samples involve categorical data, we don't call that a two sample situation, we call that a two proportion situation. So you can see then the corresponding two proportion Z test or a two proportion Z interval. Those commands are right below the one proportion test and interval commands. So this is the command for a two proportion Z test. And down here, this is the command for a two proportion Z interval. So Z scores are used when we are working with proportions. So on your calculator, the only time you'll be using Z is when you see prop next to it. When we're working with proportions, doesn't matter if it's tests or intervals, we are working with Z scores. So right now, on these screens, we're going to cross off all of the commands that have a Z in them but aren't with proportions. You will never use the Z-test command. Here's another one, Z, but this is not with proportions. We will not be using that command. So down here, here's another Z. So, but this is not stating that it's used with proportions, so we will not be using that either. So those three commands I'm advising you not to use. Oh, and here's another one, forgive me, Z interval. No, that doesn't state also that we're working with proportions. So it's actually these four commands that we will not be using. So I will tell you briefly why they are there and then why we won't ever use them. They are there if you are working for a situation that involves a mean or multiple means, but you believe that you already know the population standard deviation. The truth is, in the real world, we don't ever know the population standard deviation. We will be using the sample standard deviations in order to represent that population standard deviation. That's why we have to use t-scores with means. So these options that we just eliminated don't use those. If you are working with means, you should be using t-scores. So let's summarize those. So notice, if you have a test that involves quantitative data, oops, let me come back up here so you can see it again. If you have a test that involves quantitative data, that's a one sample situation, you should be working with a t-test. So I like to write this as a one sample t-test. Now, something else to think about, this is also the command that you would use in a paired situation, because in a paired situation, what you have really is one sample of differences. So differences between observations from the same subjects. So this can also be used for a matched pairs t-test. In other words, what I want you to realize, if you're completing a matched pairs t-test, there is not a separate calculator command. A matched pairs simply means that you are looking at pairs of observations, and you're going to be looking at differences between those observations. So you have one sample of pairs, you have one sample of differences. So that's really just a t-test. So, same thing. If you are, again, working with a confidence interval instead, but you're still working with quantitative data and you're in a one sample situation, so that involves a t-interval right here. So I prefer to call this a one sample t-interval. You could also use this in a paired setting. So this could also be a matched pairs t-interval if you wanted to. Again, what I'm trying to suggest here is t-test and t-interval. Those are one sample situations for means. So, but paired situations, matched pairs situations, those are also technically one sample situations because you have one sample of pairs, one sample of differences. So, last up then, there are only two more commands that we haven't summarized yet. So if you are in a situation where you're doing a significance test and you're working with quantitative data, but it's a two sample situation, here is the two sample t-test. Two sample t-test. And again, you can write this abbreviation, I suppose, if you wanted to, but I think it's better to be more specific. This is a two sample t-test. Then last, if you're working with a situation that requires a confidence interval and you're working with quantitative data, but it's clear you have two samples, another two sample situation, that's where you would work with the two sample t-interval. That's the last command. Two sample t-interval. So, bottom line, when you are trying to choose an inference method, these are the three things that you need to consider. Number one, does the context suggest we need a test or a confidence interval? Number two, are we going to be working with categorical or quantitative data here? And then number three, based on the scenario, is this a one sample situation? Is it a two sample situation? Or am I working with paired data? And once you've decided those, you can find the name of the test. These are the names of the tests or the names of the confidence intervals that we've studied up to this point in the class. And I just wanted you to see how those test names and confidence interval names, how those correspond to the calculator commands that you need to use.